Welcome to today's tutorial. So today I'm going to be showing you how to analyze your aeromagnetic data or your magnetic data over your study area, and how you are going to analyze, process, and give your interpretation for your data. This is going to help you, such as this. This is an analysis we did over a certain area, so I'm going to show you how you can get this done for yourself. Okay, I'm going to show you step-by-step method of doing this. Alright, so click on File, Open. We're going to do a new project. Let's call that project Mag Today's Dates. Okay, let's save. Now it opens a new clean window for us, and then go to the file, the folder where you saved the file that was given to you, okay, from your National Geological Agency, and maybe from the survey that a contractor did or whoever. Okay, so drag it. It normally comes in form of TMI, Total Magnetic Intensity Map, and there's a grid. So this is what you're going to import, and when you import it, that's it here. Okay, so the next thing you're going to do is to go to GS, load your MagMap menu, MagMap, search for MagMap M, click on M. MagMap M. Okay, this MagMap, open. The menu is up here. Okay, click on one step filtering. Okay, impute the grid which you've imported, give a name to the output file you want to create. Okay, let's impute the same name, and okay, this is going to be the name Mag Today's Dates. Okay, then impute the control file which normally comes with your in the folder of the data you acquired. Click on filter. First of all, first thing to do, processing your data need is to reduce it to pole or to equator. We are reducing to equator because our study area is close to the equator. So for you to reduce to equator, you need inclination and declination values, and I'm going to show you how we got these numbers for this location. Okay, so before I do that, before I continue, I'm going to go back and show you how this is done. It's a bit complicated, but you are going to find it. You are going to follow me, and I will show you how it is done. So first, go to the database, new database. Okay, we've created a new database. We're going to use the same name, but then we're going to add Mag database. Okay, and okay, your database is in. Go to grid and image, utilities, grid profile. Choose your grid, your original grid. Let's name the line tests. Let's give it 200 meters profile, or let's say 500 meters interval. Okay, now enter the points on the profile. Right click button when you are done. So you use your left button to select the points you want, and use your right button on your mouse to click done. Okay, now when you've done this, it imputes all the SYZ data of those points along the line. So the next thing you're going to do is to go to coordinates, new projected coordinates. We're dealing with X and Y. Okay, next under projected coordinates, you choose your ETM zone. My ETM zone is 32 knots. Alright, and then my datum is under WGS 84. Choose one that is relevant to yours. Okay, and then name, create your new coordinates, long and lat. Next, geographic coordinates. Okay, now it gives us our geographic coordinates. Okay, so the next thing we're going to do is to sample a grid. We're going to sample a grid on the that we're going to merge with this TMI grid, and that's elevation grid. We need an elevation grid. We need an elevation grid so that we can get the accurate inclination and declination of this area. All right. So how do we do that? How do we do that? Go to grid and imaging, utilities, sample a grid. So we need our elevation. We don't have an elevation grid yet, so I'm going to show you how to create an elevation grid. Copy this, your longitude, or let's copy your latitude first. Copy your latitude. Okay, Control copy, open an Excel sheet. Let's open a new Excel sheet. Open an Excel sheet and paste it. Okay, then copy, go back to Oasis Montaj, copy your longitude. The reason why I copied latitude first, because most softwares usually place latitude first for you to be able to extract your elevation. So copy, go to Excel and paste. Alright, so remember that latitude came first before longitude. So we push this down, drag your mouse to select the two column, hold shift control down, shift control down to select all, shift control down, select all, control X to copy to cut, then choose the second row and paste. Alright, so then give it the title, latitude, longitude, or let's type it completely, latitude. Okay, so we're going to name this elevation. So we don't have elevation, we are going to get elevation. Alright, so select all, Control A, Control X to cut, paste it in open a text file, paste it inside of it like this, then save. But let's save it. I'm going to name it map elevation. Save. I'm going to replace one I have already. So I named it map elevation, elevation, then close. To be able to extract elevation, go to your Google Chrome, visit this site gpsvisualization.com. okay, choose the file, go to choose file, choose the file that you saved, we named it map elevation, choose it and then convert and add elevation. So make sure you choose output as plain text. Okay, so it has converted my elevation, it has imputed my elevation. Okay, so this is the test. Download the test. Mine has been downloaded. I click to open. It was saved into my download folder. Open it. This is it. Okay, so extract it into your Excel. Go back to Excel, open new sheet, go to data, get data or from text. Okay, get data from text, go to your downloads, this is data we just imputed, import it, and is importing. Data is importing, then this is it. Okay, so they are separated by tabs in the original stuff. They're separated by tabs in the original folder. Okay, in the original file. So and they're separated by tab limiter load. it loses into your cell. So now see that you've gotten your elevation. You've gotten our elevation. Let's copy the elevation. What you just need is the elevation. Okay, shift control down button to select all of them, control C to copy the elevation, go to the other delineation sheet and paste it. Alright, so you see we have our elevation right here. Now you have inputted the elevation. Go to Oasis Montaj, copy your UTM, because Oasis Montaj usually work with UTM. Copy your longitude and replace it with the latitude. Let's copy your longitude. Copy your latitude. Copy your latitude. Paste. Okay, so remember to swap them back. Let's interchange the row, because in Oasis Montaj longitude comes first. So let me cut this column, paste it here, cut this column, paste it here, cut this back and paste it back here. So I just interchange. This is a typical SYZ grid file. So you're going to save it. You're going to save it as test or as a dot file. Okay, let's save it as a test file. Okay, save it as tests. Name it elevation data. Save. So close the Excel. Close the Excel. While this is still on, let's import ASCII file. Okay, import ASCII file for elevation. Import the file. The file I want to import is this. Go to desktop where we saved it. Go to desktop, I will save it, and we're going to import it. Elevation data, open, wizard, delimiter, okay, with spaces and all that. Okay, just next, finish, save the templates. Okay, and we're going to import the file this template is this. Okay, import data into the current. No, we're not importing it into the current database, and new database, let's call it elevation database. Okay, so this is our elevation database. Okay, so it's run to the latitude. So I want to create set current XYZ coordinates. Let's call longitude eastings. Okay, while latitude is our northings. Okay, while elevation is elevation. Okay, so it has given them, assigned them XYZ values. Okay, so that when we want to grid, we can grid elevation. Okay, so we have gridded the map. All right, we have a grid right here now. Okay, so now with this grid, it will now reflect here. Okay, mark elevation grid. So I minimize. So now I'll get back to my Mac database. Okay, back to my Mac database. So how do I now impute my elevation column? You go to grid and image, utilities, sample a grid, and we're going to call this elevation. Name it elevation. Okay, let's go to elevation, and then we select that elevation grid that we created. Okay, so you see it imports your elevation column. Alright, so next thing we do is make this. Now that we've created this elevation, the next thing to do is to upload the IGF menu. IGF, click IGF is right there. It has imported the menu. So IGF channel, you click on IGF channel, or to leave this, you can choose our survey date to be this survey should be around 2001 or so, around 2001 slash, let's say 0101. Okay, and our input channel, our longitude is so it's 2001. Okay, alright, our longitude channel, we choose longitude, latitude, elevation channel, elevation that we created. Okay, and we don't have total field yet, we don't have inclination yet, so we just name them TF, INC, and DEC. Okay, so they do not appear automatically. You go to your list, choose your total field. Okay, choose your your inclination. Okay, and choose your declination. Okay, so it calculates them automatically, so you see what you have here. So this is basically the inclination and declination you have around this place. So we're going to just take the average. Let's say the average is 14.3. Okay, we can say choose 14.2 or 14. Let's choose 14.3. Let's choose 14.3 or 14.2. For our inclination of our declination is minus 3.1. So, and now we have gotten, you've seen how we get these values. I told you it's going to be complicated, but that is how you extract your inclination and declination and total field and elevation for the area of study. Okay, so now you go back to Meg Map, one-step filtering, filter. So we say we're going to be using minus 14.3, and minus 3.1. If you do not use the right inclination and declination, it's going to affect how your reduced equator will place the data on the right body, the right place they ought to be. Okay, and that's that. Okay, let's create an output grid file. Then okay. Alright, this is your reduced to equator map. This is your map now reduced to equator. So you see the differences and compare the two maps. Okay, so you see the differences wherever you put this crosshair, you're going to see how it has adjusted. Remember, this is the raw file, this is our RTE file. Okay, so now the next thing we're going to do is we're going to, from here we can do every other filtering that we want to do. Is you can do your analytical signal. Your input grid now is the file that you've already RTE'd. Okay, your RTE file, which is the mark, alright, the mark 220124. okay, that's the map we did our stuff on. So you can still copy the same folder name, the same file name, and just add analytical to it. Okay, and okay, so to create an analytical signal map for you, you have an analytical signal map. So here we have an analytical signal map. Okay, so with this we can see structures, we can see areas where you have intrusions. Around this area we have quarry sites, a lot of quarry sites, because there are a lot of intrusions of hard rocks into a segment terrain. We have ridges of sandstones, and places where you have hard rocks usually reflect like this. Then your segments, you have a lot of segments, deeper segments around this area. So this is what your analytical signal look like. You can also have your vertical derivatives. Your vertical derivatives, choose your derivatives, go to derivatives. You can have any form of derivative. You can have your x direction is horizontal. You can go, your y direction is also horizontal. You can go in z direction, that's vertical derivative is z. Okay, you say okay, and let's name it vertical derivative, that's vd, one vd, that's first order, because we left, remember it is at the first order 1. Okay, so vd, 1 vd, and okay, so you can have your vertical derivative map this way. This is a vertical derivative map. You want to say okay, just cancel this, I don't want to. Alright, this is your vertical derivative map for the study area. Okay, so there are more you can do to this through interactive step-by-step filtering. You prepare a grid. There's so many things you can do, so many things. One more thing I want to show you is in node menu. I want to show you how to look for CET grid analysis. Okay, CET grid analysis, open your CET grid analysis. It is open. So when you have your CET grid analysis, you go to texture analysis, standard deviation. Going to get your, remember to use your grid file which you have RTE'd. You have done reduce to Equator 2. Okay, that's one we are going to use, the RTE original grid. The output data, we are going to call it input file name. Remember to put your input file name as our RTE file, RTE grid, the one that comes after we have our TMI. Then use your RTE, the reduce to Equator. Standard deviation, let's call it SD. apply. Okay, so it has created a standard deviation map. You go back to CAT delineation. Okay, phase symmetry values, choose 5 for each of these. 5, 5 and 3. Okay, it already named it automatically phase symmetry. Okay, apply. With this you can easily delineate all the bodies, understand the general orientations. Now look at that. So this can easily locate our veins, our faults, our fractures. Okay, here we have intrusions of vein, minerals and all that. So this is phase symmetry, and it is very important in finding minerals, locating all minerals, especially hydrothermal veins.